Well, welcome. In this video, we're going to be looking at properties of logarithms. Now, we've been talking about logarithms in the previous videos, so if you haven't watched those, you want to make sure that you do. But in this video, we're going to be talking about some properties as far as dealing with how to simplify some logarithms. If we have multiple logarithms, maybe how to combine the logarithms into a single logarithm, and vice versa. But to start out with, let's look at this first property. This first property says if we're dealing with any base b, then the log base b of 1 is always 0. And we get that because b to the 0 power is 1. Putting this in logarithm form allows us to use the fact that the log base b of 1 is always going to be 0. Because remember, logarithms are always equal to exponents. So when you're trying to figure out what exponent would you apply to b to get 1 as your answer, it's always going to be 0. Doesn't matter what the base is. Now, because b to the first power is always b, we get this next theorem. This next theorem says that the log base b of b is always going to be just simply 1. So if I had the log base 7 of 7, what exponent would I apply to 7 to get 7? Well, b to the first power. So again, anytime the two bases are the same, your answer is going to be just 1. Well, sometimes we deal with bases that are the same, but we have an exponent. So if I have this base and this base are the same, your answer is always going to be whatever the exponent is. And you've seen that before, like if we have log base 3 of 3 to the 5th power. Before we were asking ourselves, what exponent would I apply to 3 to get 3 to the 5th power? Your answer is 5. Well, now we can see because of this rule, anytime this base and this base are the same, your answer is the exponent. So I can see now because of this rule that my answer would be 5. Now let's look at this next property. Actually, these next two properties are important to understand. So this first one says log base b of x times y. We can break that up into log base b of x plus log base b of y. Now this is especially useful because there are times where we have separate logarithms like this, and we need to combine it into a single logarithm. And so to do that, we would multiply the two values together. Or there are times where you have something already multiplied together and it'd be easier, or there's for some reason, which you'll see in a second, we need to break that up. In that case, if we need to break up those two pieces that are in parentheses, we break them up by addition. Now, if we're dividing, we're going to break them up by subtraction because division and multiplication are opposites. So the opposite result is that we're going to subtract the logarithms. Or there's times where it's already separated. By subtraction, we need to write it as a single logarithm, in which case we would divide the two values. Well, let's look at these first examples here. Now they tell us that the log of 2 is approximately 0.301, and the log of 3 is approximately 0.477. We're going to figure out what these answers would be without using a calculator. So for example, I want to figure out what the log of 6 is. Well, you might say, well, I have no clue. Well, what you got to do is you got to figure out, well, how can I use 2 and 3 to get 6? So think about that for a second. How can I use 2 and 3 to get 6? Well, hopefully you're thinking that, well, 2 times 3 is 6, which is true. And because of what we just talked about with this previous property, we know that we could rewrite this as the log of 2 plus the log of 3. Well, guess what? We know that the log of 2 is 0.301. Add that to the log of 3, which is 0.477. And again, we could do that without a calculator. If you add those together, you get 0.778. Let's look at the next one, log of 20. Now, sometimes they're going to give you a number like this where you can't use both the 2 and 3, but maybe you could use the 2 and another number, or the 3 and another number. So can you think of maybe how, I'll give you a hint with this one. Can you think of how you could use the number 2 and one other number to come up with the log of 20? Well, maybe you're thinking 2 times 10, which is true, but you might think, well, how does that help me? Well, let's start out. We know that we could break this up into the log of 2 plus the log of 10. We know the log of 2 is 0.301. And think about the log of 10. The log of 10 is what exponent would you apply to 10 to get 10? So in other words, These two bases are the same, so we just talked about that property. If those two bases are the same, your answer is 1. So 0.301 plus 1 gives me 1.301. And we were able to do that without a calculator. Now the next one's a little bit trickier. How can we use 2 or 3 and get 5? Now you got to be careful. 2 plus 3 is 5, but that's not going to help us at all in trying to use any of these properties. So let me maybe just tell you what we would do in this one. And this one, we're going to do similar to the previous problem, where we're just going to use 10, but this time we're going to use 10 divided by 2, because 10 divided by 2 is 5. But you might say, well, wait a minute, why couldn't I have used 2 plus 3? Because there's no way to break that up. Okay, we don't have a property that would break this up for us. So we're going to leave this as, like I said, 10 divided by 2. And we're going to break that up now into two pieces. So this will be the log of 10 minus the log of 2. The log of 10, we just said that's the same as 1 because this base and this base are the same. So it's going to be 1 minus log of 2. Well, 2 is 0.301. And when you go to subtract those, we get 0.699 would be your answer. Now this last one is actually a typo. This should be 50, the log of 50. So you might say, well, wait a minute, I don't know how to do that one. Well, we can figure out, sometimes we can use what we got as one of our previous answers to help us get this answer. So we just found the log of 5, and you might recognize that log of 50 would be the same as the log of 5 times 10. And so now I can break that up to be the log of 5 plus the log of 10. And the log of 5 is the same as 0.699. The log of 10 is 1, so our answer would be 1.699. So sometimes we have to use one of the previous answers that we got to be able to get a final answer. That's how we can use some of those properties of logarithms to find other logarithms that we wouldn't know without a calculator. Now before we get to the next property, let's look at this computation here. Let's say if we have log base b of 9, we could break 9 up into 3 squared, or we can simplify 9 to be 3 squared, which is the same as 3 times 3. And using that previous property, I could break that up then into log base b of 3 plus log base 3 of 3, which, if you notice, are the same thing, so that would be the same as 2 times a log base b of 3. Now you might say, how is that helpful? Notice what we had here with the previous part, when I broke that up into log base b of 3 squared. That exponent, that 2, became, or we can put that 2 in front of the logarithm, so it'll be 2 times the log base b of 3. Or look at this one. Here they simplified this one, log base b of 2 to the 4th power. And again, that exponent, that 4th power, we put in front of the logarithm. And you can see the process is similar to the previous one. So here's what I'm getting at. This next theorem is called the logarithm of a power theorem, which tells you anytime you have an exponent, we can park that exponent in front of our logarithm. So it'll be m times a log base b of x. Or it works backwards too, where if you have a number in front of a logarithm, that number can also be used as an exponent for that value. So let's look at some examples where we're going to use this property. So again, this time we know that the natural log of 17 is 2.833. We want to find what this would be without using any technology. Well, this 10, that's an exponent. We can park that in front of the natural logarithm. So this would be the same as 10 times the natural log of 17. Well, again, we know that the natural log of 17 is 2.833. So this would be the same as 10 times 2.833, which multiplying that times 10 will move the decimal to the right one place, so your answer would be 28.33. Let's look at the next one. This is the same as a natural log of 17 to the 1/4 power. So now we can put that 1/4 in front to be 1/4 times the natural log of 17. And again, we know that the natural log of 17 is 2.833. Now you might say, I can't do this without a calculator. Well, if you had a simple four-function calculator, what I would call a baby calculator, where all we can do is add, subtract, multiply, and divide, we could take 1/4 times 2.833 and get an answer of 0.708. Let's look at the next one. I actually want you to try these two on your own. So knowing that the log of 3 is approximately 0.477, I want you to find the log of the cubed root of 3, and find the log, if you can't do this one, the log of the cubed root of 300, which might be a little bit trickier, but I think you can do it. So I want you guys pause this video and hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did here with this first one. So we're trying to find the log of the cubed root of 3, so hopefully you recognize that you could write that as the log of 3 to the 1/3 power. And that 1/3 power we could park in front of the logarithm, so it would be 1/3 times the log of 3. And we know the log of 3 is 0.477, so we would take 1/3 times 0.477. And do that on your baby calculator, your simple calculator, and you get your answer of 0.159. Now the next one's a little bit more complicated, but hopefully you attempted it and tried to work it out, and maybe even got the right answer. So we're going to start out by writing this as the log of 300 to the 1/3 power. Now I'm going to do two steps in one here. I could take that 1/3, park it in front, so we'd have 1/3 times a log, but 300 is the same as 3 times 100. Now I can break that up. Now it's going to be 1/3 times my total answer. It's going to be 1/3 times that whole thing, so you want to put parentheses around this to make sure that we do the log of 3 plus log of 100 first. And the log of 3 and the log of 100, we can figure out those pretty easily, because log of 3 is 0.477. Log of 100 would be 2, because again, our base for the log is 10, so what exponent would you apply to 10 to get 100 to be 2? Add those pieces in parentheses there, you get 2.477. Take 1/3 of that answer, and you get your final answer of 0.825. So that is how you do part B there. Now the next example that we're going to look at is going to be taking multiple logarithms and writing them as the log of a single number. So it's kind of like the order of operations when we're trying to simplify something, and we always look to simplify exponents first. So we're going to do the same thing here. This 2, remember, is an exponent for that 5. So I'm going to write this as, so this would be the log of 40 plus the log of 5 squared. And yes, 5 squared is 25. So to save myself some writing, I'm just going to change that to 25. And now we can use that property of a logarithm to say that since we're adding and the bases are the same, we're going to multiply these values together. So this would be the same as a log of 40 times 25. And since 4 times 25 is 100, 40 times 25 would be 1,000. So this would be the same as the log of 1,000. Now technically our answer would be 3, but that's not what they're asking us to do. They're asking us just to figure out how to write this as a single logarithm. So that would be my answer. Let's try the next one. Again, I always look to see if there's any exponents. Now there are no numbers in front of any of these logarithms, so there are no exponents. So now what I'm going to do is I'm going to combine these. So now adding means that we would multiply those values together. Subtracting means we would divide by that value. So to write this as a single logarithm, I'd say it's a log with a base 2. Now we're going to multiply 3/5 times 5 halves together. We're going to take that divided by 3. So again, the reason why, since we're adding these two logarithms together, we would multiply those values. Since we're subtracting, we would divide by our final value there, divide by 3. Now if you notice in the numerator, we can simplify that. The 5s would cancel out, leaving us with 3 halves in our numerator, but we don't want to leave 3 halves in our numerator and divide by 3. So remember what we do is to simplify this, I'm going to do this. I'm going to say we have 3 halves currently divided by 3. To simplify that, we're going to take and multiply, we're going to multiply by the reciprocal of the denominator. The reciprocal of 3 is 1/3. So now you'd see that the 3's cancel out, leaving us with 1/2. So essentially what this means is that we would have the log base 2 of 1/2. Why don't you guys try see if you can't try these next two on your own. The next two are very similar to the previous ones we've done. Just make sure that you always look to see if you have an exponent that you can apply first. So go ahead and work these out, and so pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did here with this first one. This first one is a little easy because you want to write this as a single logarithm, so it'll be the since they all have the same basis, we can combine these together. So it would be the natural log of 14 times 2 divided by 7. Now you could simplify that before multiplying it. If I wanted to, I could take 14 divided by 7 and get 2, and 2 times 2 would be 4. Or I could take 14 times 2 and get 28, and 28 divided by 7 is also 4. But remember, it's the natural log of 4 would be your final answer. Okay, so now let's look at the next one. The next one, this 2, remember, is going to be an exponent for the 1/2. This 5 is going to be an exponent for the 3/5. But that does not mean that we're taking 1/2 times 2. Hopefully you didn't make that mistake. And 3/5 times 5. That's what the publishers were hoping that you'd make, but hopefully you avoided that mistake and wrote it like this. Because 1/2 squared would be 1/4, and 3/5, the 5th power, you're going to need some help with the calculator on that one, would be 243 over 3,125. And again, leave these as fractions. So now what we want to do is we want to combine these as a single logarithm. So to do that, we're going to multiply those two values together. And again, you'd use your calculator to get 243 over 12,500. It'd be the log of 243 divided by 12,500 as your final answer. So let's look at some other ones. These are a little bit easier. We want to rewrite these as a single logarithm. So this would be the natural log, 1/3 times the natural log of t plus the natural log of 5. Again, this 1/3 would be an exponent for the t. So this would be the natural log of t to the 1/3 power plus the natural log of 5. So in this case, we would multiply these two values together. So our answer would be the natural log of 5 times t to the 1/3 power. And that would be your answer. So why don't you guys try this next one on your own. Again, this time we're just using variables instead of numbers here. So it's almost a little bit easier than the other one. So why don't you guys pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did on this one. So again, first you should recognize that the 7.2 and the 1.8, those are exponents for the t and the u. Now by the way, this minus, a lot of times in math we keep that minus with the number, but in this case you don't want to do that. We want to leave the 1.8 as just a 1.8 and leave the minus behind. So when you do that, it'd be the log of t to the 7.2 power minus the log of u to the 1.8 power. Now we want to simplify this. So to simplify this time we're subtracting instead of adding, so hopefully you didn't make that mistake. So instead of multiplying these two values together, we're going to divide them. So it'll be the log of t to the 7.2 power divided by u to the 1.8 power. Well, that's it. If you notice in my notes, I do have another example, but we're not going to worry about that one. So we're going to end this video here. So with that, good luck now as you work on your assignment.